Go. Okay. Uh, Thank you, students. Today I am going to take a new type of problem, that is 2 by m. That is only two jobs will be given and the m machine will be given. If that is the case, how to do the problem? That is what our aim here. Okay. So within 15 minutes, I have to finish this particular discussion. So let me take the problem first and I will explain you how we have to solve this problem. Right. Now this is the problem given to us. Job 1 and job 2, only two jobs, but A, B, C, D, E. Okay. So how many machines are there? One, two, three, four, five. Five machines and two jobs. How we can solve this type of problems? Okay. So look at this. This is the question format. Sequence will be given A, B, C, D, E, and time also will be given. A takes 1 hour, 2 takes 2 hours, C takes 3 hours, and D takes 5 hours, and C takes 1 hour to do the first job. The second job, C takes 3 hours, and the A machine takes 4 hours, and D takes 2 hours, and E takes 1 hour, and B takes 5 hours. Okay, so if that is the case, how to do the problems? So it is a purely graphical method. The previous method, that is as we have discussed earlier, n by 2 or n by m, or mathematical models. I mean, we are finding out the optimal sequence and other things. But here it is not the case. Graphical method we have to use here. Okay. So let us go how to do the graphical methods. Now look at this particular graph. The graph, the horizontal line I am taking as job 1. Horizontal line I am taking as job 1. And vertical line I am taking as job 2. Horizontal line job 1 and vertical line as job 2. Okay, right. Now look at the question given to us. On the job 1 line, you take the sequence A, B, C, D, E. A takes 1 hour. So for A, we are taking 1 hour, and then B takes 2 hours. So 2 hours I am taking there. Okay, right. Then C takes 3 hours. That means 2 plus 3. How many guys are here? 3 plus 2. 3 plus 3, 6 hours. So 6 hours takes C. Then afterwards you take D. It takes 5 hours. So what will get 6 plus 5, 11 hours. So the 11 hours I am giving in the green color as D. That is the machine D takes 5 hours. Next C takes 1 hour. So that 1 hour from 1 to 11 to 12 I have given 1 hour by red lines. Okay. So this is on job 1 line we have to do. The same way the job 2 also we have to mark on job 2 lines. Take for example here machine C takes 3 hours on job 2. So on the vertical line 2 units, sorry, how many units? 3 units. 3 units you take for C machine. Then afterwards 3 plus 4, 7. You come here 3 to 7. It is the time taken by machine A to finish job 2. So you are writing A machine here. Afterwards B takes 2 hours. So you take 2 hours from 7 to 2, 9 hours. This is what the time taken by B on job 2. Similarly, E 1 hour there. Where to from from 19 from 9 to 10, from 9 to 10, 1 hour. Then afterwards, it takes B 5 hours. 5 hours it takes. So 10 to 15, we are giving the B machine. Machine takes 5 hours to finish this particular job. The next step is that the intersecting area we have to find out. On the x-axis, see the first machine A. On the job 2, what is where it starts? A starts. So intersecting of these two, intersecting of this A and on job 2 line, okay, on job line, this intersecting area I am taking as A. Then afterwards come to the second job. Here first to 3, the first hours to 3 hours, which takes machine B takes. Now here where to where? From 16 to from 10 to 15, from 10 to 15 B takes. So the intersecting area of this and this, that is I have given in a clear way. I have given the intersecting area. I make it so extend this, extend this, extend this, extend this. The intersecting area is B. And this is what B area. The rectangle shows the B processing time by the machine B processing time for both job A and B. Now similarly for C. For C, this is the area, extend this, okay. For C, this is the area, extend this. The intersecting area is this. Intersecting area is this. Similarly for D, extend this, extend this, extend on the job 2 line, extend this, extend this. The intersecting area is D is this. This is the machine D processing on job 2 and 1. Okay, that is this particular rectangle area. The last E is from here to here, extend this, similarly extend this, okay, and you will get the intersecting area as this, that is A, okay. This is the second step that you have to do. Now, the next step that we have to draw the straight line starting from the origin with 45 degree. With a 45-degree line we have to draw from the origin. So it will go there and it will touch here and it will go there. When it goes here, the vertical line, to the next box, we have to go in a straight way. We should not go like this and join here. Okay. We have to go like this. If the box is away, then you have to draw the line, vertical line. Okay. Then afterwards, reaching the terminal points of this box, again 45 degree, you have to draw the lines, and it goes through this, and this is the point, the intersection of the total time taken by job 1. Total time taken by job 1, 12 hours, and this is total time taken by job 2, the intersection of these two. So this particular point is the intersection of processing time on job 2 and processing time of job 1 on this intersecting point. Okay. Now how to find out the total elapsed time? Total elapsed time. Now look at this. To do the job 1, the machine A starts here, then it goes like this, goes like this, goes like this, and it stops here. Then after set, no work for the job 1, only job 2 is done up to this. That is 3 hours. 3 hours, the job 1 is ideal. Okay, that's what you have to understand there. If it goes like this, that means this machine, this job is ideal. When the line curve comes like this, then it means the second job is ideal. If the curve goes like this, then first job is ideal. That's what we have to understand. Okay, so the curve from here, it goes up, goes up, goes up, and then turns and goes here. So this is ideal time for job 1. So look at this. So from here to here it goes, then ideal time, then processing time. So total processing time is 12 hours. Ideal time is 3 hours. So total 15 hours. 15 hours is the total elapsed time. Otherwise, you take the perpendicular line. So there is no ideal time for job 2. Therefore, 15 hours comes. So anyway, whether by taking job 1 or job 2, you have to get the same total elapsed time. Otherwise, the problem is wrong. Now, what's the precedence? Now, look at this. On job A, A is proceeding, then on job 2, because on the job 1, A is the initial stage itself starts, but on job 2, on the third hours only it starts. Therefore, job precedence for the first machine, A machine, is job 1. Similarly, you look at job B. Job B starts first hour in the job 1, but job B starts on the 10th hour on the job 2. Therefore, job 1 precedes job 2 by second machine. Now come to the third machine precedence. The third machine, first job starts at the third hour, whereas the second job starts at the initial stage itself. Therefore, job precedence for C is job 2 precedes job 1. You now come to the fourth machine. The fourth machine on the first job, it starts at the 6th hour, but whereas on the second hour, it starts at the 7th hour only. Therefore, job precedence for D is job 1 precedes job 2. The last job we talk about, job 5th on the first machine, that is E machine, is 11th hour, whereas E starts there on the 9th hour itself. Am I correct? 9th hour itself starts, yes, 9th hour itself. So the job precedence for the E machine is that job 2, that is second job precedes the job 1. So this is the way we can solve any uh, sequencing problem of the type as we have seen just before. I mean, 2 job and M machine. These type of problems can be solved by this way. Okay, so this is how we can do the problem, that is a sequencing problem. Okay, so let me talk on that. The first step is that we have to find vertical line. The second step is that we have to find out the intersecting area. Then we have to draw the 45-degree line, and the 45-degree line will give you the ideal time and total time taken, and thus we can finish any type of problems. Okay, so thank you very much for being with me for the first 15 minutes. The next video I will come with another problem. Thank you for that.